Here we are at example 8 from the 1.2 set of notes. We're asked to evaluate the following limit as x approaches 0 of this particular function. Now, it looks a little intimidating just because of this absolute value inside of there, but surprisingly, it's actually not that bad. And in fact, it directly relates with what we've been talking about dealing with like left side and right sided limits. So let's go ahead and break up our 2 using left and right sided limits. So we have the limit as x approaches, looks like we're approaching 0 from the left of this particular function. So we have x over the absolute value of x. And over here on the right side, we have the limit as x approaches 0 from the right of x over the absolute value of x. If you were to try direct evaluation, you'd get 0 over 0. So we're just gonna go ahead and try things left and right side. So again, this is our right. Here is our left. Now, this is where things, I guess, get like, I don't even necessarily want to say like harder, but conceptually just a little different. Now, if you are taking the limit as x approaches 0 from the left side, all right, so here's 0, and you are to the left of him, meaning you're somewhere over here. Well, then that means that you are in the negative x values, right? Because this is all x's, you're in the negative x value. So you have some x value that's negative. So x is going to be less than 0, meaning that it's negative. Well, in that event, we then end up with the limit as x approaches 0 from the left. Now, I have no idea maybe what x value I'm going to choose because we have so many to potentially choose from, right? I mean, you're just approaching 0 from the left. You're not saying exactly what x value you are. Maybe you might be -3, you might be -1, you know, whatever. It doesn't really matter, but as long as you are approaching 0 from the left, okay, of our function x over the absolute value of x. Now, if you think about it, as long as this value happens to be negative, well, in that event, we would end up with some negative x value, depending on whatever number we chose, over the absolute value of negative x. And the absolute value of a negative number just comes out to be a positive number. In this case, it comes out to be positive x. So negative x divided by positive x just comes out to be -1. Now on the right side, things are handled very, very similarly. The only difference is that you are to the right of 0, so you have some positive x values and you're trying to get closer and closer and closer to 0. So x in this case is going to be larger than 0, giving us some positive. Well, in that event, you still end up with the limit as x approaches 0 from the right side of our function x over the absolute value of x. And any value that you plug in here, you know is going to be positive, no matter what it is. And as a result of that, we end up with some positive x value divided by some positive x value that you plugged in here. Well, the absolute value of some positive x value still comes out to be some positive x value. And so you end up with x divided by x. Well, x divided by x is simply just 1. You know, anything divided by itself is just 1. And so we should see something, some limit, no matter what x value we chose, to be 1. So as a result, what this function looks like is, no matter what x value you plug in for x, it's going to be 1. Now on the left side, when you graph this, we ended up with -1. Again, no matter what you threw in there for x, all of them were negative, and when you throw them in here, this is what we end up with, -1. And since you can't actually be 0 because you get that undefined statement, or that 0 over 0 indeterminate form statement, you end up with actually 2 holes right here at 0. You can actually even graph this using your graphing calculator and confirm this. Now, because we kind of see this like jump happening when we're, to the left of 0 and to the right of 0, because we see that jump, there's no smooth transition between these two limits, then that limit just simply would not exist. So because we see this jump, then the limit as x approaches 0, not specifying left or right, of our function x over the absolute value of x, again just because our original function wasn't specifying left or right, will just simply come out to be does not exist. But we had to show that using left and right side limits to actually kind of prove why this isn't working out. All right. So again, that is example 8 from our 1.2 set of notes.